molar mass, and amount. We're also going to go back to this formula here, which we've done already, okay? And we're going to use this little ratio thing here. Okay? And we're going to set up an equivalent fraction as well. So we're going to combine these two things together. Okay, so we've done that before. That was a couple days ago. And then yesterday we did mass and molar mass stuff. And now we're going to combine the two. And this moles here, okay, of course this would be moles here, yes? Okay, so moles here, that actually and that are the same thing. Okay, those two are the same thing. We'll do two separate formulas for this. We're not going to combine it all together. That's silly. Okay, we don't need to do that. Just keep it nice and simple here. Okay, so if you're converting between the number of particles or the molecules and the mass, that's kind of what we need to work on today. So we already know particles and moles. So we've done 1 mole, 6.02 times 10 to the 23. Okay, this is all in Google Classroom too, I believe, or it's going to be on your notes here that you can copy in here. Okay, so we've determined how to go between moles and mass and stuff like that. Today we're going to focus on all that combined together. Okay, and the most important thing is we need to know the number of moles. Okay, moles is the key here. It's kind of the intermediate thing between the two equations that I wrote down earlier here. So if you're given the number of molecules and atoms, you're looking for the mass. So find the number of moles, use a ratio. Okay, we talked about that. Okay. So this you can copy down on your sheet that I gave you guys. Okay. So if you're looking for the number of molecules or atoms and are looking for the mass, you're going to fill in the number of, find the number of moles, I should say, use a ratio. Find the mass, you're going to use n equals little m over big M. Okay, so you guys can write that down there. I think you need to write these two parts in here. Okay. If you're given the mass, all right, then we're going to use the number of moles, so that there, and then we're going to find the number of molecules or atoms, use a ratio. Okay. And we have 3 examples here on your sheet. You don't have enough room to do them there, so don't try. Okay. We want to make sure stuff is spread out. Like you know, your homework looked good today for the most part, guys. Spread out. Make sure it's nice and neat so you can understand it. Okay. Don't try and jam stuff into a little tiny section there. It's never going to work. All right. So that's kind of the pattern we need to go with. Okay. Now, regardless of what we say up here, guys, here's what I want you to think about. Okay. Let's focus on what the question is asking us. What variables, okay, do we need to solve this? So it says here, how many molecules? How many molecules? Here's an important part, water, yes, okay. Here is an important part, tells us something right there too, a number, yes, okay. So let me ask you this. What are some of the things we know from this question? What could we, what's some variables that perhaps we know? Yep. Sure. Water. Yeah. Molar mass. Yes. So we could find little m there. Yes. And we know what water is. It's H2O. So we could find the molar mass. Yes. Okay. So H2O. Yes. We can put that in there too. Okay. And like I said, make sure you copy this down somewhere so you have this example. Okay. All right. Let me ask you this. So you're saying I know the mass, little m, and I know big M. Okay. In fact, we could find it right now. Yes. Okay. So 2 hydrogens and an oxygen. Add those up, and it's 18.02 grams per mole. Periodic table. Yes. 18.02 grams per mole. Okay. So look, I have the mass and I have the molar mass. What can I find from little m and big M? And you should know this, obviously. It is what? Huh? N, yes. Moles, yes. Amount, right? So do that, because that's what you need to do, obviously, because why else would they tell you mass and molar mass? You got to find N, right? So we're going to use this formula here, and we're going to say, okay, let's find big M, or sorry, let's find N, sorry, amount, moles, right? And I said, okay, the mass is 1,000 grams, oops, 1,000 grams, yes, and the molar mass is 18.02 grams per mole, and I can find N from that. And I'm going to divide those two numbers, of course, and I get 55.49, yes? Okay, roughly 55.49, and I'm actually just going to do this moles. Okay, means that number is going to go on 4938, 567, whatever, good enough. Okay, that is not my answer yet, though, right? If the question was find the amount, we'd be done. This would be yesterday, yes? That's all I need to do for yesterday's stuff. Today, we're just going to add on one thing, guys. We're going to use the ratio, right? We need to find, look, what does it say? How many molecules? How many molecules? Is this molecules here? Is that molecules? No, that's moles, right? So use the ratio that we used a couple days ago and say, hey, look, I know this, though. 1 mole is 6.02 times 10 to the 23 molecules. Okay. And I know how many moles I have. Apparently I got 55.49 yada yada yada, right? Yada 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 moles. And if I cross multiplied and solve like we did the other day, we should be able to figure out how many molecules, right? That's what's left. So I cross multiply and solve. All right. 1 times x is x, yes? And 6.02 times 10 to the 23 times 55.49, yada, 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 okay? And I will get my number of molecules, all right? Good? Okay? And that's all there's to it, guys. These are going to be the same steps. I'm telling you right now. This is it. Okay, but we obviously need to make sure we know the molar mass, that compound. The rest is just kind of following the pattern, right? So when you do this, now I don't know how you guys do this on your calculator, and unfortunately I already started here, but let's go back to here for a second. Here's what I do on my calculator. I don't know. You know, if you want the unrounded number, and I don't know if you guys know this, because sometimes I do this, and sometimes people are like, what are you doing? But look, the first number, of course, is 1,000 divided by 18.02. Well, that's not tricky. 1,000 divided by 18.02, and there's your answer, 55.49, yada, 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 right? Et cetera, et cetera. Now, what I do is I figure out, okay, am I multiplying those numbers, or am I timesing them, or dividing them, or what am I doing, right? So it looks like I have to multiply this number here times 6.02 times 10 to the 23. And maybe you guys know this, maybe this is silly for me to say, but if you got one of these, you can just literally hit the times button, and it already takes the answer from above, yes? Okay, or if you ever want to do this, you can go, if you get an answer and you want to use it somewhere else, you can do second negative. You see that little A and S there? That means answer. So that's the answer there too, right? So if you ever want to take the answer instead of writing the entire number out, A and S, answer is there, right? So you can just simply go times, that'll take the answer, and then you just type in 6.02 times 10 to the 23, and there you go, okay? Do not forget though, look, we're talking about molecules. That number is going to be huge, yes? So whatever you do, I always get this. In fact, I just got this the other day. Well, it's 3.340 times 10 to the, what is it again? 25, okay? Don't forget this part, okay? Because if you forget that part, so sometimes I get this answer, 3.34, right? Wow, you know, 3.34, that's good, but you forgot the times 10 to the 25 part, right? Which is a little different, You know what I'm saying? Like, it's like 24, 20, 23 zeros different kind of thing. It's a big difference, yes? So when you take a really big number and you times it by a number, you should get a really big number, yes? It shouldn't be 3.34. So don't forget that part. You know, once again, significant digits, guys. I guess actually in this case, how many significant digits do I have here, guys? 4 actually in that case, right? 1,000. The zeros at the end count. So that's 4. So I guess in my answer here, I forgot what it was here. 3.34, actually I probably should say 1, yeah? Because that's a 0.7. So I'd round that up to a 1. Okay, is that good? So 3.341, let's do that. 3.341 times 10 to the 25. And of course that is molecules, yes? And that would be my final answer, okay? You're just taking the two parts, okay? Mass and molar mass, and then of course the ratio, 1 mole is 6.02, okay? And the other question I'm going to give you eventually here, maybe it's not the next one yet, we're going to go backwards. So I'm going to give you this, and we're going to work backwards and get back to the mass, okay? Yep, yep. Okay, let's look at this one. How many atoms are in 55 gram sample of iron? Okay, so let's think about this here again. How many atoms? Okay, let me ask you this. If I ask you how many atoms or molecules, what should the number be? What should the number be? Small or really big? Really big, yes? Right? It takes millions and millions and billions and trillions and pentillions, okay, of atoms to weigh, yes? Okay? So it should be really big, yes? My answer should be really big here. And what's this again? 55 grams, what is that telling you? What letter? Is it N, little m, big M, molecules, little m? Okay, so write it down. And of course they're talking about iron, yes? Well, iron looks like that, yes? Iron, okay? So, once again, how many atoms? Okay, what's all the information I have here? I have the mass, okay? So right away, look, I'll tell you right now, if you want, you can start here, okay? And you can even write this down too, guys, okay? Now, and remember, this could be molecules, atoms, ions, compounds, desks, pennies, whatever. Okay, pencils, don't really care. 1 mole is 6.02 times 10 to the 23 of anything. So whatever you want to put there. Okay. So, and of course, maybe you want to include a fraction there. Yes. So those are the two things that you're always going to start with. Okay. In this case, we have 55 grams. Yes, that should probably go over here. So I could say, hey, that's 55 grams. Okay. The key, okay, everything is about N, the moles. This and this are the same, yes? That is how you get from this formula to that formula, okay, if you want to call them formulas. Or that ratio to that ratio, okay? N and N are the same, those two. So I need to find N if I want to go over to there. 55 gram. Iron has a molar mass of 55.85 grams per mole. And of course I can find N. Okay. I hate that. Okay, so divide those two. Yeah. I'll just do this one on the calculator here, just for convenience sake here. So I get about 0.9847 moles. Okay. And then I'm like, okay, now I have N, right? So now I can say, oh, where can I put that now? And I guess the other question you have to ask yourself is, did I answer the question? Because maybe the question is only, what's the amount? What amount of iron do I have? How many moles of iron do I have? Then you'd be done, right? In this case, they want to know how many atoms. So this, of course, would have to be atoms here. And I have what? 0.9847 moles here. And I'd cross multiply and solve. Okay? 1 times x, 6.02 times 10 to the 23 times 0.9847. Don't round that number because you can affect your answer if you round it. Okay? Multiplying those two together, you get 5.92837 times 10 to the 23 atoms of iron. And probably your best answer in this case, we'd go back to the question, okay? In the question, how many significant digits do I have? How many? 2, yes? Do you agree? 55? 2, yeah? So let's have 2 in my answer. And I would just say, okay, well, let's just call it 5.9 then, times 10 to the 23 atoms. Okay? Good? Okay? Exact same as yesterday, except we're using the ratio as well. Okay? All right. Let's go to the next one here. Is that good? Everyone got that there? Okay. Let's get you guys to do this one here. How many formula units, in other words, how many compounds, how many molecules you could say, I guess, are in 25 grams of sodium chloride? So go ahead and do that. Kind of follow the same pattern we've been doing before, guys. Quickly, let's go. Okay. Sodium chloride's a 1 plus. Sodium's a 1 plus, chloride's a 1 minus. Swap and drop. Okay. 1 plus, 1 minus ionic compound. That's why they're talking about formula units, basically compounds. Okay. 25 grams. So divide by that by the molar mass. 25 divided by 58.44, and we get about 0.4277 moles. And then, of course, we want to know the number of formula units, so basically molecules or compounds. So we then use this ratio here, 1 mole, 6.02 times 10 to the 23. You can call them formula units if you want. Probably shouldn't. Formula units, or molecules or compounds or whatever, okay? Okay, and we have 0.4277. That would go there, and we cross multiply and solve. Okay, yep. Hmm. 0.4277, 25. That's what we should have. Are you sure? Yeah, maybe just, I don't know, just double check you got the same molar mass? Maybe just wrote it down wrong. Okay. Okay. Multiply that by 6.02 times 10 to the 23, of course, your final answer, yeah, 2.58 times 10 to the 23. When you round to 3 significant digits, because there is what? Oh, sorry. You know what? That doesn't make sense. Look, there's how many significant digits in the question, actually? 2, right? 25, that's 2. So really, this probably should be better, you know, 2.6 times 10 to the 23, yes? And that would be the formula units that we need there. Okay, 2.6. Now, once again, I'll probably tell you how many digits that I want there. So I'll say, hey, record your answer to 3 digits or whatever kind of thing, or 2 or 4 or whatever kind of thing. Yeah. Okay. Good. So those are all the same, guys. There's 3 examples of those. Let's do backwards now. So look at these ones. Okay, and these are actually on that sheet too, guys. Notice here, okay, we're going to change it from what is the mass now. So what is the mass, right? And now, like I said, we're going to change it on you. And we're going to say, hey, this is how many atoms you have. This is how many atoms are on the scale. What does the scale read, basically? Okay. And of course, this is times 10 to the 23 here, atoms of copper. Okay. And copper, by the way, we know is copper. Yes. Okay. So we know that. We know the number of atoms. Okay. So look, real quick here, before we get too far, I just want you to kind of look up here for a second. Okay. Think back to the first three that we did. The first three, I gave you what in the question? Look, in the question, question, question. You have the what? The mass, yes, grams, correct? So we started here, yes? Correct? Because I know this, yeah? So I started there. But now look what they're telling you. Atoms. And it's a really big number, right? So where do I start here? Should I start over here? Or maybe should I start with this formula here? Probably this one, yes? Because they're telling me a really big number, and I know the number of atoms, molecules, ions, compounds, whatever, okay? So I probably want to start here, is what they are telling me there, yes? So I'm going to start here with this one this time, and then I'm going to go over to this one, okay? Once I find n, look, then I know n here, yes? Because those two n's are the same. So that n here is going to be this n right here. Those two are the same, okay? So here we go. Watch. Let me get rid of this and that for a second. And we'll just kind of get rid of this for a second here, and I'll just write this over. Another way to think of this question is this, okay? Let me pose this to you for a second. They say, what is the mass? What is the mass? So do we not have to solve for little m, right? So if I rearrange the formula like you guys did yesterday, I get that, correct? Let me ask you this. Do you know n? Well, not yet, but we will, right? Do you know the molar mass of copper? Yep. That we can look on the periodic table, right? But I need to know this and this. This I kind of know. I'll look that up. This I can calculate from over there, right? So we have those two parts that we need for mass. So this is 3.01 times 10 to the 23. Now in this particular case, we're talking about atoms, and atoms here as well. And I'm going to solve for n, right? Moles. Okay. Now, the one thing you have to get right about this is a couple things. We did this the other day. This goes back to a couple days ago. Cross multiply, right? 6.02 times 10 to the 23 times n, cross multiply, right? And 1 times 3.01 times 10 to the 23, okay? And we need to get n by itself, so we're going to divide both sides by 6.02 times 10 to the 23, yes? So if I divide this by 6.02 times 10 to the 23, that'll get rid of that. And I'll divide this by 6.02 times 10 to the 23, and that is the calculation I need to do, yes? And you're going to see a similar pattern. You're basically going to be dividing by 6.02 times 10 to the 23 for these questions, right? So what I need to know is, okay, when I divide this by this, what does n work out to be? Do not forget to write this in properly on the calculator. We talked about this last day. Brackets, or you got to use the e thing, okay? I don't care, but we need to divide that by that, okay, the whole thing. Make sure, because otherwise you're going to get some E47 thing again, or 46 actually in this case, and that's not going to be good. So even if you want, give it a try right now. Make sure you get this number here, which I have a suspicion is 0.5, yes? Okay? Now that one worked out pretty nicely because, of course, we kind of plan that for you there. So 0.5 is what you should get, okay? If you see anything after that, once again, brackets is the key there, yes? Now, I know 0.5 moles, so look, I can come over to here. What is the mass of 0.5 moles of copper, Cu? And Cu is what, 63.55? Okay, so 63.55 grams per mole. And if I multiply those two together, I get 31.775 grams, okay? And once again, guys, we will tell you how many numbers we want there or whatever, but if you look back at the question, really, that also should be a little indication to you. How many significant digits are in this number right here? How many? 3, yes? Okay, 3, pay attention. So I probably should have 3 in my answer, okay? So to get 3 in my answer, I'd say 31.8, probably, yes? Okay, all said and done. Good? Yeah. Okay, and that would be the mass of that one there. Good? Okay? You're only using these 2 parts, guys, and once again, okay, there's only 2 ways to really ask these questions for you, okay? Good? Let's take a look at the next one here. Is that good for everyone? Okay. Okay. We have times 10 to the 21 carbon tetrachloride. Okay. So here we go. Pay attention. Here we go. Once again, they're asking you for the mass. Okay. You may want to start with both formulas, of course. You might say, how do I know that I need both formulas? Maybe that's, do I really need both formulas? Because on the test, some questions are going to be what's the moles, what's the mass, what's the molar mass, whatever. And some questions will be how many molecules or whatever. But you got to take a look at the information, of course. It says what is the mass. So first things first, I'd probably want to solve for mass. Yes? So I'd rearrange the formula to solve for mass. Okay, if it says what's the mass, I need to know what a little m is. It's N times big M. I can actually probably do a little bit of this right now without even doing anything. I don't know N, but molar mass, carbon tetrachloride, looks like that. And I can most certainly find the mass from that. Okay, it's 4 chlorines, carbon tetrachloride, and a carbon. And that's 153.81 apparently. So I can put that in there right now. Okay. Good? Yes? That comes from 1 carbon and 4 chlorines. Type it in, periodic table, 153.81. Okay? I still don't know N though. Okay? I guess I better find N. How am I going to find N? Well, obviously I need to use this piece of information right here. Now, that says molecules. Molecules. That is not N. Okay? Could you imagine? Think about this for a second. If you took this number here, if you did, and put it here, 5.45 times 10 to the 21 times 153, what's your answer going to be? Pretty darn big, isn't it? I mean, think about that. 545 with 18 zeros behind, or 20 zeros, times 153. My goodness, that's huge, right? That's how many grams you'd have? Wow, that's heavy, right? That is heavy. No. So that's probably not what we need to do. We need to probably convert it, yes? So that's where this would come in here. 1 mole, 6.02 times 10 to the 23 molecules. Okay. And I'd want to put 5.45 times 10 to the 21 molecules down here and figure out N. And once again, the homework's on the sheet there. Yeah. Make sure you keep the units the same, right? Moles, moles, molecules, molecules, yes? Okay. Cross multiply and solve. I'll give you a little tip. Okay, look. If you want to save some time, it's always the number divided by 6.02 times 10 to the 23. Okay? I shouldn't put that there. Molecule. Well, that's molecules there. It just didn't turn out very well. Okay, I should probably put that. Molecules. Okay. So dividing those two is what you're going to do. 6.02 times 10 to the 23 is always the number on the bottom because we're always going to be dividing by that to solve for n. Okay. That works out to be, let's see here, times 10 to the what, 21. Messed that up. Let's try that again. Oops, messed that up too. Divided by 6.02, oops. Oh boy, times 10 to the 23. So I get 0.00905. Okay, good, yes. Now I know n, so that's going to come over to here, 0.00905 moles. And I'm going to multiply those two together. Okay, so times 153.81. And your final answer should be this here. It's about 1.39246 grams. That's an acceptable answer. That makes sense. Okay. And how many significant digits should I keep, or how many numbers should I keep here? How many are in the question? 3, yeah? Right? So let's keep 3 in the bottom part here. Okay. And I would say, well, that's 1.39 grams. Good? Yeah? Okay, so 3 number 5.453. So I want 3 numbers in my answer. Okay? Good? All right. One more real quick here. Let's get you guys to do this one. This one's magnesium nitrate. So go ahead. Real quick here. No, the option.